I'm Anil Kumar, and in this video we will learn a very important basic concept about finding relation between sine and cosine. The question here is how to find cosine of an angle when its sine value is given to us, right? So the question very clearly is that let us say we have angle theta. So we are given sine theta. So sine theta is given. And the question is find cosine theta, right? Normally we'll write this as cos theta. So that is the question for us. How do you do it? Now this is such a common thing in almost every example. You have to do this kind of a thing, right? So we have two different approaches here. So let me begin by, let us say, starting with the right triangle. So that is one of our approach. Now in a right triangle, what is sine theta? Let us sketch one. And let's take an example. Let us say we have sine theta equals to 2 over 3, right? So I'm just taking any general value. And to represent this, what I will do, first case, I will take my triangle in quadrant 1. So 2 over 3 means that hypotenuse is 3 and the opposite side is 2 units long, right? So kind of, let us say, so the opposite side is 2 units and this hypotenuse is somehow 3, okay? So what I will do here is I'll just make a triangle here whose height is 2, right? And connect it with the origin. And I say that this angle here is theta, where 2 is the opposite side, since sine theta is 2 over 3 and hypotenuse is 3. Is that okay? So that triangle represents sine theta equals to 2 over 3. Now since this is a right triangle, I can find the third side. What should be this side? Adjacent side should be 3 square minus 2 square square root, correct? Which is 9 minus 4 square root, which is square root of 5. So I can write this side as square root of 5. Is that okay? Now once I get that side as square root of 5, I get the value of cosine theta. So cos theta should be equal to adjacent over hypotenuse, which is square root of 5 over 3. Does it make sense? So this is one way of finding cosine theta from sine theta. Now there is another way which we use Pythagorean identity. Now see carefully what happens. Pythagorean identity is that sine square theta plus cos square theta equals to 1. Now if I know what sine theta is, I can find cos theta by rearranging this formula. So we say cos square theta equals to 1 minus sine square theta, or cos theta equals to square root of 1 minus sine square theta. And whenever you do square root, you write plus and minus, right? Because square of a negative number is also positive. Now this formula can help us get the answer. So we say cos theta equals to plus minus square root of 1 minus sine theta is 2 over 3. So we'll write 2 over 3 whole square. Is that okay? Now that is equals to plus minus square root of 1 minus 4 over 9. Square of 2 is 4, square of 3 is 9, or it is equals to plus or minus common denominator of 9, 9 minus 4 over 9 square root. And that gives us 9 minus 4 is 5, so square root of 5 and square root of 9 is indeed 3. So we get the same answer, but note the difference. We have plus and minus. So if I use Pythagorean identity, I get two values of cos theta. You see, very interesting, right? Two values of cos theta. And if I use my right triangle, I get just one. Can you tell me what have I missed? That is very important to understand. And that's the reason why I have taken up such a simple case. Now sine theta is positive. You remember the cost rule, right? What does that tell you? It tells you that sine is actually positive in quadrant 1 and also in quadrant 2. Do you get the idea? So when I say sine theta is 2 over 3, my triangle could have been in quadrant 2 also, right? So that is to say, I could have this triangle, exactly the same triangle in quadrant 2. And in that case, what happens? Look here, same triangle reflected. So we have sine value as 2 over 3. That means opposite side, right? Over the hypotenuse. Adjacent side is square root of 5. But negative this time because it is towards the negative side, left side of origin. So from here you get cos theta as equals to negative square root 5 over 3. Do you see that? So if I am given sine theta value, then I am expecting two values for cosine theta, not just one as we wrote. So to be very specific, we'll say that our angle theta is actually between 0 degrees to 360 degrees. Okay, in that case, we should be looking into all four quadrants. Perfect. So if sine theta is positive, we are looking into these two quadrants. If I take sine theta as negative, in that case, these two triangles could have been in quadrant 3 or 4. Whatever the case may be, we'll get two results, right? So Pythagorean identity helps us to calculate the correct answer very easily. But here is a picture to explain you how we get these two answers. I hope this helps you to understand the concept. So whenever we will be solving trigonometric equations, keep in mind that when sine value is given to us, we should consider all the quadrants where that value is possible and then answer the question, or we could use the Pythagorean identity to calculate the result algebraically. I'm Anil Kumar, and I hope this concept helps you to understand how to calculate the cosine of an angle when sine value is given to you. Now for you as a test question, let us say sine theta equals to minus 2 over 5. You need to find the value of cos theta, okay? So do this. You could use either of these approaches, but if you use that approach, don't forget to consider two quadrants. Minus means sine is negative in quadrant 3 as well as in quadrant 4. I hope that helps. Thank you and all the best.